And just before we get started with the presentation today, I'd like to give you this information in case you are interested in additional support outside of this webinar. So we do offer assistance with all aspects of the dissertation. So if you are interested in more one-on-one support outside of this webinar, you can use the information you see here to contact us and learn more about the types of assistance that we can provide. So, and again, before we get into the presentation, I'm just going to give an overview of what we will be covering today. So this webinar is on the quantitative results chapter. So we'll only be covering components of the quantitative results chapter. We will not be discussing qualitative results chapters. And so first, we'll just talk a little bit about the purpose of the results chapter, and then we'll talk about the different components that are required for the results chapter. Starting with the introduction, we'll talk about data collection and preparation, demographics, assumptions testing, analysis of the research questions, and then the summary. And then at the end of the presentation, I'll have an opportunity for you to ask questions. So if you do have questions during the course of the presentation, you may put those into the questions section. And then at the end of the presentation, I will go through and answer your questions if they have not already been answered throughout the course of the presentation. So we will save the questions for the end. So first, let's talk about the purpose of the results chapter. Really, the purpose of the results chapter is to present the data and the analyses that answer the research questions and or your hypotheses. So in the first or the preceding chapters of the dissertation, you're establishing why you need to conduct your study and how you are conducting your study. Once you get to the results chapter, you have conducted your study already, you have collected your data, you have analyzed it, and now you need to present the results of those findings. You need to show the reader what you have found. And so you want to present the findings for each research question and hypothesis with a clear statement that answers each. So by the end of the results chapter, you should have an answer to every research question or an answer to every hypothesis clearly stated. And you don't want to go much farther in terms of interpretation than answering the research questions or the hypotheses. You want to save further interpretation. So for instance, tying the results back to the literature for your discussion chapter. And I do want to note that although we will be covering the components that are most common or most commonly required for the dissertation based on our experience with many different schools, you do want to follow the specific guidelines or requirements that are specific to your school or degree program. So we're covering the most common components required for the results chapter, but your school may have slightly different requirements. They may require fewer sections or they may require more sections. So you do want to make sure you defer to your specific school's guidelines in terms of what you need for the results chapter. So now let's talk about the different components of the chapter. And like most chapters, you'll usually start off the results with a short introduction where you restate the purpose of the study, you restate your hypotheses and research questions, and then you can just simply outline the contents of the chapter or the sections that the chapter will contain. The purpose statement can just be a brief version of the purpose statement, or it can be a verbatim restatement of the purpose statement from your previous chapters. And when you restate your research questions and hypotheses, those should be stated verbatim as they appear in previous chapters. So it's important throughout your dissertation document that every time you present the research questions and the hypotheses, those are stated using the exact same wording every time they are presented in the document. And then the outline of the contents can just be as simple as listing off the different section headings that will appear in the results chapter. After your introduction, you'll want to talk about your data collection and preparation. So here you're going to be summarizing the data collection procedures that you conducted, and importantly, note any changes from your originally proposed procedures. So it's often the case that when you do your proposal, so you're going to propose a certain data collection method and certain data collection procedures, during the time between your proposal phase and your results phase, you may encounter issues that cause you to change your data collection procedures or your the methods that you're using. So if this is the case, if you did have to change your procedures from what you originally proposed and your data collection ended up being different from what you originally proposed, you want to note those changes. And different schools will have different requirements for how they want you to present this. So sometimes schools will actually want you to go back to your methodology chapter and change it to update the data collection procedures that you actually followed. Other times, schools will want you to preserve the originally proposed data collection procedures in your methodology chapter and instead just note any changes in the results chapter. So again, you want to look at your specific school's requirements to see how you should handle changes to the data collection procedures. But those should be addressed at some point, whether it's in the methodology chapter or the results chapter. And in terms of your data collection, you want to discuss your response rate and attrition. So you want to talk about your sample size, how many total cases or participants you had, if you had to remove any cases or participants, how many did you have to remove, for what reasons did you have to remove people? So it's possible that your study has certain inclusion criteria and not all of the participants or the respondents met those inclusion criteria. So you may have to exclude certain people. And so you want to describe step by step how you excluded people and how many people were excluded. After you talk about that process, you want to arrive at a final total sample size that you'll be using for your analysis. And if applicable, you may need to conduct a post hoc power analysis if your target sample size was not met. So you may have conducted a power analysis during the course of your proposal to determine your target sample size. If you did not meet that target sample size, which is often the case in dissertation research, it's very common to fall short of your target sample size. You may need to conduct a post hoc power analysis to determine what the power of your analysis is, given that you didn't reach your target sample size. And in this section, you may also want to discuss your preliminary data preparation steps. So this can involve checking data for accuracy, how you're handling missing data and checking for outliers, as well as coding or recoding any data or computing composite scores for certain variables. So checking data for accuracy is especially important if you're doing, for instance, a survey study where you had people fill out paper and pencil surveys and you had to manually enter the data from the paper and pencil surveys into an electronic format. Because if you do that, that introduces the opportunity for data entry errors. So you want to go back and make sure that there are no data entry errors and just generally check to make sure that all of the values that are in your data make sense and are within plausible ranges for each variable. You also want to discuss in detail how you're going to handle missing data. So it may be the case that if you're doing a survey study, for instance, some participants may have failed to answer some of the questions, or they may have skipped some questions for one reason or another. It's very likely that once you collect your final data that you'll have some participants who are missing some responses. So you want to discuss how you're going to handle those missing responses. Are you just going to completely exclude people who are missing any responses at all and only include people who answered every single question? Or are you going to try to include people who are missing some responses? And if so, how are you going to handle the missing data points? Are you going to replace the missing data points using some form of replacement, such as an imputation? Or are you just going to do a pairwise exclusion of participants based on the data that they provided? And in terms of coding and recoding data, you want to make sure that you follow the instructions for any survey instruments that you're using in terms of computing scores for those surveys or coding the data. So it may be the case that you have to recode values for certain variables. You may have to do reverse coding. So you want to describe that process as well. And so here are just a couple of examples of how you might write up a data collection and preparation section. So here we just have an excerpt where we talk about the initial number of survey responses we got. We talk about how we exclude participants who didn't complete a certain percentage of the questions. We talk about our final total sample size, and then we talk about how we're going to handle our missing responses. And here's another example where we talk in a little bit more detail about the data collection, the time period for the data collection, again, how many total responses we received. We talk about how we're excluding certain participants and how many were excluded. We talk about missing data, and we talk about our final total sample size. And here's an excerpt that shows an example of how you might write up a post hoc power analysis. So again, if you're in a situation where you do have to conduct a post hoc power analysis, this is how you might write up that power analysis. So you talk about what statistical tests you're doing, you talk about the actual sample size you obtained, and then you report the level of power that you got based on the sample size for each of those statistical tests. After you've talked about your data collection and preparation, you can start getting into your analyses. And first, you may want to start off with just some basic descriptive analyses covering demographic variables and other variables of interest in your study. So you want to present descriptive statistics for most of the variables in your study, especially demographic variables and the variables related to your research questions. And typically, if you have categorical variables such as gender or ethnicity, you'll want to report frequencies and percentages for those. And if you have continuous variables such as age in years or GPA, then you can report means and standard deviations for those types of variables. If possible, if you have a report of demographic characteristics, you may want to try to compare the demographic characteristics of your sample to the population. So if you have statistics available for the population, you may want to see how closely your breakdown of demographics in your sample resembles the population. So that can give the reader an idea of the representativeness of your sample. And then if you have, for instance, survey instruments that involve multiple items and you need to report reliability coefficients for those instruments, you'll want to present those reliability coefficients such as Cronbach's alpha for the measures that it applies to. And so here are some examples of how you might write up some descriptive or demographic information for your study. So you may have some narrative talking about demographic characteristics. You may also want to present demographic characteristics in a table. And it's important to note that whenever you present a table in your results, you first of all want to reference that table in the text. So you never want to have a table in your results chapter that is not referred to in the text. So you see here, we have table 1 here, and we refer to table 1 in the text. And you also want to make sure that your table comes in close proximity to where you reference it in the text. So for instance, you don't want to talk about table 1 in the text, and then you don't present table 1 until 2 or 3 pages later. The table should come in close proximity, usually immediately following the paragraph where it is first referenced. And here's another example of a table presenting descriptive statistics for continuous variables. So you see here, you have a table presenting mean standard deviation as well as minimum and maximum values. And here's an example of how you might present reliability statistics. So we have a table presenting Cronbach's alpha coefficients, and we have some narrative describing the reliability of our measures. Now, after you've covered your descriptive statistics, you can start getting into discussion of the actual analyses that you're conducting pertaining to your research questions and hypotheses. But before you dig into that too deeply, you want to talk about the assumptions of those statistical tests. So if you're doing virtually any kind of inferential testing, whether it's a t-test or an ANOVA or a regression, you will have to test certain statistical assumptions to ensure that they are met so that you can accurately interpret the results of those tests. And so you may want to have a section in your results chapter that covers the assumption testing. And it's important to note that the assumptions test can be presented in their own dedicated section, usually preceding the analyses of the research questions, or they can be presented alongside the analysis of each research question. And again, refer to your specific school guidelines for how they want this information presented. And so for all the assumptions tests that you need for the analyses of your research questions, you want to list and discuss those tests. So you want to discuss how each assumption is tested, what the result of that assumptions test is. You want a clear statement of whether that assumption was met or not. And then if the assumption was not met, you want to discuss the action that you're taking to account for the fact that the assumption was not met. So for instance, if you're doing a t-test, you may need to test the assumptions of normality and homogeneity of variance. So you want to discuss, how are you testing normality? Are you using a test like a Shapiro-Wilk test? Are you using a visual method such as a histogram? Are you doing some other method to test for normality? You want to discuss what the result of the assumption test is. So for normality, what was the result of the Shapiro-Wilk test? What did you see in the histogram if you're using a histogram to test for normality? You want to say whether normality was met or not. And if normality was not met, what are you going to do about that? Are you going to transform the data in some way to try to make it normal? Or are you going to run an alternative test like a non-parametric test that doesn't require the normality assumption? And so here are some examples of how you might present the results of assumptions tests. So here we have an example with normality that we're testing with a normal PP plot. So we talk about how we're testing normality. We make an interpretation of the plot saying that we're not seeing significant deviation from the normal line, and we say that the assumption is met. And here's another example where we describe some assumptions testing. In this case, we also talk about what happens if one of our assumptions is not met. So you can see in the highlighted section, we see that we have detected an outlier in our data, which violates our assumption of no outliers. And then we talk about how we dealt with this. So we're saying that we excluded the outlier from our analysis. And once you've covered all of the assumptions testing and ensure that if your assumptions are met, or what you're doing if your assumptions are not met, you then present the results of the analyses that answer each research question hypothesis. So you want to organize this section in order of your research questions and hypotheses as they appear in your dissertation document. So that'll just make it clear to the reader and easier to follow. So for instance, if you have 5 research questions, you just want to present your analyses in order of research questions 1 to 5. You don't want to jump around or present it in some other order, like start with research question 2 and then jump to research question 4 or anything like that. You just want to present the analyses in order as they appear in the rest of your document. And like your data collection procedures, you want to also note any changes from your originally proposed data analysis procedures. So again, between your proposal phase and your results phase, it may be the case that you had to make some changes that impact what statistical analyses you're doing. So you may have a data analysis plan presented in your proposal. If that changed when you get to your results chapter, if you had to conduct some alternative analysis, or you had to change your analysis in some way, you want to talk about how that changed. For each analysis, you want to clearly identify the variables that you're using for each analysis. So for something like a t-test or an ANOVA, identify your independent and dependent variables. If you're doing more of a correlation or a predictive type of analysis like a regression, you want to identify your predictor, criterion, or covariate variables. You want to report the appropriate statistics associated with each test, which can include p-values, effect sizes, and confidence intervals. So for instance, if you're doing a t-test, you want to report your t-statistic, the p-value associated with the test, the effect size, which might be Cohen's d, and so on. And then if the statistical analysis that you're doing requires post-hoc testing, for instance, if you're doing an ANOVA that requires a post-hoc test, you want to report the results of those post-hoc tests. Importantly, for each analysis, you want to include a clear statement that answers each research question or hypothesis based on the results of the analysis. So again, for each research question, you should be able to state by the end of this analysis section whether the hypothesis was met or not, or whether the hypothesis was supported or not. You should have an answer to each research question. So if, for example, if your hypotheses are presented in null and alternative format, you want to make a clear statement of the null hypothesis was rejected or the null hypothesis was not rejected. So now let's go through some examples of how you might report the results of some common statistical tests. So we'll start with just a t-test. And here's an example of a t-test where our results are not significant. But you see here, we start with a discussion of what test we're conducting. So we're saying we're conducting a t-test. We're identifying our independent and dependent variables. We present the results of our t-tests, so our t-statistic with the degrees of freedom in parentheses, our p-value for the t-test, which in this case is not significant at the 0.05 level, and then a measure of effect size, which in this case is Cohen's d. And then we give a basic interpretation of the result of this test, and again, a clear statement in regards to our hypothesis. We say the null hypothesis was not rejected because our result was not significant. And then if applicable, present a table showing relevant statistics for the test. In this case, for a t-test, we might show the means and the standard deviations for the groups that we're comparing. Now here's another example of a t-test. In this case, we're showing a result that did turn out to be significant. Again, we start off the same way, saying what test we're conducting. We identify our independent and dependent variables. We present the statistics for our t-test. In this case, it is significant because our p-value here is less than 0.05. We present our effect size, Cohen's d. We give an interpretation. Our test is significant. It indicates that there are differences. And then again, we have a statement for our hypothesis. In this case, because it is significant, we can say that the null hypothesis was rejected. Here's an example with an ANOVA. So again, we state what analysis we're doing. We state our independent and dependent variables. We present the results of the ANOVA. In this case, for an ANOVA, and this also generalizes to the result of any test involving the F statistic, you actually have 2 degrees of freedom, and both should be reported in parentheses next to the letter F when you're presenting the results of an F test. So the first degrees of freedom is the numerator degrees of freedom, and then the second degrees of freedom is the error or denominator degrees of freedom. You present your F statistic, and then the p-value associated with that test. In this case, it's greater than 0.05, so that would indicate that our ANOVA is not significant. And we make a clear statement in regards to our hypothesis. The null hypothesis was not rejected. And again, you may want to present a table presenting relevant statistics for the test. Again, for an ANOVA, you might present means and standard deviations for each of the groups that you're comparing. Here's another example of how you might write up an analysis, this time using a Pearson correlation. So here, again, we state that we're conducting the Pearson correlation. We state what variables we are looking at for our Pearson correlation. And then we present the statistics for our Pearson correlation. So we present the correlation coefficient itself, the Pearson R, as well as the p-value associated with the correlation coefficient. And in this case, because we have significant correlations, we can say that the variables are significantly related to each other, and we reject our null hypothesis and make that clear statement. And again, you may want to have a table showing relevant statistics for the analysis. Here, we just have a table showing our correlation coefficients. And here we have another result for a correlation type of analysis, this time for a regression. And so for a regression, you typically want to report the results of the overall regression, which is, again, an F test. You want to report the significance level or p-value for that overall regression model, as well as the measure of effect size, which is the R squared, or the percentage of variance explained. Because our overall regression model is significant, it means that we are significantly predicting our outcome variable. And so our null hypothesis is rejected. We make that statement. And then you may want to go into the results for the individual regression coefficients. So you want to state which regression coefficients were significant and what was and do a basic interpretation of those regression coefficients. So was it a positive or a negative relationship? And what does that mean? And typically for a multiple linear regression, you might just have a table like this where you present the results for the individual regression coefficients. And so after you have presented all of the results for the analyses for your research question, and you have a clear answer for each of your research questions, the final part of the results chapter is typically just a summary of those findings. So you want to summarize the chapter contents or just the findings that address each of the research questions. You may want to restate the answer to each research question or hypothesis. Again, state whether each null hypothesis was rejected or not, and then just provide a basic transition to your discussion chapter. And so that brings us to the end of the presentation on the quantitative results chapter components. Again, if you are interested in additional support outside of this webinar, you can use the contact information you see here to get in touch with us and find out more about the services that we provide. But now I'll go ahead and get into the question portion of today's webinar. So I'll see if you have any questions. And so if you do have questions, you can feel free to type those into the question section now. And I'll see what questions we have so far. And let's see. So the first question is, if you're using archival data, how would data collection and preparation differ? So this is a good question. So if you are using archival data, it's going to be a little different from if you're collecting primary data, because that usually just involves the process of how you obtained that archival data. So it may be the case that you got the archival data from some publicly available source, like a website. It may be the case that you had to contact some organization or data administrator in order to get access to that archival data. So in your results chapter, you just kind of want to summarize that process. How did you access the data? At what time did you access the data? Because sometimes archival data sets can be updated. So you want to specify the time period that the data was accessed, the time period that the data were originally collected, those types of things. So you really just want to kind of give a little overview or summary of how you obtained the data, and if this was any different, again, from how you originally proposed to obtain the data. Another question is, how do you write or word a hypothesis for process analysis? Well, it kind of depends on exactly what you're doing in process, because the process macro that's used in SPSS or other stats programs is capable of doing a number of different things. So it can do things like mediation or moderation. And so your hypotheses are going to differ depending on exactly what type of test you're doing. So if you're doing something like mediation, you might have a hypothesis of, is there's a significant indirect effect of your independent variable through your mediator variable, for instance. If you're doing moderation, you might have a hypothesis of there's a significant interaction between your moderator variable and your independent variable. It's also worth noting that we do have other webinars that discuss how to construct your research questions and hypotheses. So if you do want more information on how to develop your research questions and your hypotheses, I'd encourage you to look at our other webinars on that topic. And a follow-up question to that, how do you write results for process analysis, which I've seen uses bootstrap methodology? Really, again, it depends on exactly what you're doing with process, but process is usually similar in terms of the write-up to a regression, because most things in process are done in the framework of a regression analysis, whether you're doing mediation or moderation. So your write-up for process will typically involve reporting the results for the regression. You say how many bootstrap samples you're using. And if you're doing something like mediation, where your indirect effect is based on confidence intervals for the indirect effect, you want to report those confidence intervals and so on. But in short, the the write-up for a process analysis is going to be similar to the write-up for a normal multiple linear regression analysis, depending on exactly what you're doing in process. So another question is, in assumption testing, do we need to use multiple approaches, for example, using QQ-plot, histogram, and Shapiro-Wilk methods to test for normality? This is a really good question, and it really depends on what your original data analysis plan was and what specific assumption that you're testing. Normality is kind of a special case because it's usually preferred to use multiple methods to assess for normality, just because no single method for testing normality usually gives you an end all be all answer to the assumption, or it's often the case that there are strengths and weaknesses to different approaches for normality, for instance. And we actually have a past webinar that we did that specifically discusses normality and different ways to test for the normality assumption, the strengths and weaknesses of those approaches. So if you're more interested in that, I would refer you to that particular webinar. But the answer is, specifically for normality, yes, you may want to use multiple approaches because, some approaches like the Shapiro-Wilk test, for instance, may not give you a full picture of normality for your data. There may be other types of assumptions where maybe only one test is sufficient. So if you're testing homogeneity of variance for a t-test, for instance, it's usually sufficient to just conduct a Levine's test and use that to test that particular assumption. So another question is, can you please explain the concept of effect sizes? Is it compulsory to always report Cohen's d value in all analysis? So effect size, the concept of effect size is how great in magnitude are the differences between groups, or the strength of the relationships of the variable of the relationships between variables. So when you do these tests, like for instance a t-test or an ANOVA, to see if there are differences between groups on a certain dependent variable, if you just conduct the t-test with no effect size reported, all the t-test is really going to tell you is if the difference between the two groups is significant or not. It's not going to tell you exactly how big that difference is. And that's what the effect size tells you. So an effect size like Cohen's d tells you what the magnitude of that difference is. And that's the general purpose of effect size, is it tells you the magnitude of the difference, or the magnitude or strength of the relationship, which in some cases may be more important than just whether that difference or relationship is statistically significant. And in terms of should you always report Cohen's d, the answer is no, because Cohen's d is an effect size that is specific to things like the t-test, but other types of analyses will have different measures of effect size. So for instance, a multiple linear regression might use the r squared as a measure of effect size, or an ANOVA might use the partial eta squared as a measure of effect size. So the actual type of effect size or the effect size statistic that you report will depend on the specific type of analysis that you're doing. So another question is, do you have recommendations for software to run the data? So it really depends on what's available to you, what you're comfortable using, because normally when you take a statistics course, they might teach you a specific software package such as SPSS. We actually have our own in-house software called Intellectus Statistics. That's browser-based. You can sign up for it through a subscription and use it through any internet browser, so it doesn't require you to install a program on your computer, and is relatively user-friendly compared to a program like SPSS, where you kind of have to learn how to use it. So those are what we commonly use, either SPSS or our own software, Intellectus Statistics. So another question is, how do you know if you should use hierarchical versus linear multiple regression analysis? So that's going to depend on how exactly you're choosing the variables to put into your regression analysis, or how those variables are organized. So the purpose or the difference between just a regular multiple linear regression and hierarchical regression is the steps at which the variables are entered. So in a hierarchical regression, the variables are entered in certain steps. So you might start with just entering demographic or control variables, and then you might enter your main predictor variables or independent variables of interest to see how the results of the regression change when you enter new variables into the model. A regular multiple linear regression just enters all of those variables in at the same time. So it really depends on specifically your research questions and hypotheses, and whether or not it makes sense for you to enter variables and steps, if that helps you answer your specific research questions and hypotheses. And then another question, how do you determine for data cleaning if it's best to include missing data for some of the response items versus missing data for all of the instrument items? Again, this will depend on your specific analysis plan. And there are different approaches to dealing with missing data depending on various factors, such as the amount of missing data and the nature of missing data. So it may be the case that you may want to exclude respondents who are missing very large amounts of data, and then include participants if maybe they're missing only a few responses. And then you may need a strategy for replacing missing values for people that you do decide to include in your final data set, such as an imputation strategy. And there are various different imputation strategies that people will use depending on the nature of the missing data. So whether the data are missing at random, or if the data are not missing at random, there are different recommendations for exactly what types of imputation strategies you might use. We also do have past webinars that discuss data preparation. So if you have more questions or are interested in more information on that specific topic, I'd encourage you to look at our past webinars on data preparation. And then the follow-up question to that, is the data cleaning done through the survey website like Qualtrics, or is it done through SPSS? So typically, the survey service like Qualtrics or SurveyMonkey would not clean the data for you, although they might provide some basic analysis services. It really depends on what you're signed up for with that particular survey site. But usually, you would have to do the data cleaning and preparation yourself through a stats program like SPSS, or in an electronic spreadsheet program like Excel. And let's see, I believe that that is all the questions that we have got in so far. So if you do have, or if anyone has any additional questions, and feel free to post those questions now. And I'll allow about a minute or so for any additional questions. Okay, so it doesn't look like any more questions are coming in, so I'm going to go ahead and end our session for today. So thanks everyone for attending. And again, you can use the information on your screen here to contact us for more information about the support we provide, or you can look at our webinar page to look at information on upcoming webinars if you're interested in looking at other webinars on other topics that you may find useful. So again, thanks everyone for attending today. I hope everyone found this helpful, and I hope everyone has a great day.